In this figure we have a square ABCD whose side length is 5 units and a quarter circle whose radius is also 5 units. We need to find the radius of the blue circle, and I will show how to find this radius using two different methods. So let's start with method 1. With this method, we will draw a diagonal of this square by connecting the points D and B. This diagonal will pass through the center of this circle and let this point be point O. From this point, we will draw a vertical line down to the bottom of the square and another horizontal line to the left. Then let this point down here be point F and the one to the left be point G. Now, because the radius of this circle is r, then the distance from F to C is also r. Then if the distance from D to C is 5 units and this part is r units, then the distance from D to F is 5 minus r. The same situation we will have to the left. The distance from A to G is r and the distance from G to D is 5 minus r. Now let's take a look at the distance from D to O. Because the radius of this quarter circle is 5 units and the radius of the blue circle is r units, then we can say that the distance from D to O is 5 plus r. I will write this to the right. D, O equals 5 plus r. Now let's take a look at the right triangle D, G, O. In this triangle, the left side is 5 minus r, the top side is also 5 minus r, and the hypotenuse is 5 plus r. Then we can use the Pythagorean Theorem to write that 5 minus r squared plus 5 minus r squared equals 5 plus r squared. So let's write this equation to the right. 5 minus r squared plus 5 minus r squared equals 5 plus r squared. If we solve this equation, then we will find the radius of the blue circle. We will start by removing all the parentheses, and for this we will use the following formulas. A minus b squared is a squared minus 2ab plus b squared, and a plus b squared is a squared plus 2ab plus b squared. So when we raise a binomial to the second power, we get a trinomial. Then according to these formulas, 5 minus r to the second power is 25 minus 10r plus r squared. We could also remove these parentheses by using FOIL. Next, we will have another 25 minus 10r plus r squared. Then to the right, 5 plus r squared is 25 plus 10r plus r squared. Now let's cross 25 on both sides and r squared on both sides. From here, we will move 10r to the left. Then we will have 25 minus 10r plus r squared minus 10r and minus another 10r from the right. Then on the right side we will have 0. Now we will combine together negative 10r, negative 10r, and negative 10r. Then we will have a quadratic equation, r squared minus 30r plus 25 equals 0. To solve this equation, we will use the quadratic formula. So if we have an equation of the form ax squared plus bx plus c equals 0, then the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Then according to this formula, r equals fraction 30 plus or minus square root of 30 squared minus 4 times 1 times 25 all over 2 times 1. Inside the square root, 30 squared is 900, and 4 times 25 is 100, and 900 minus 100 is 800. Then r will be equal to 30 plus or minus square root of 800 over 2. Now, to simplify this radical, we will write 800 as a product of 400 and 2. Then we will have 30 plus or minus square root of 400 times 2 over 2. Square root of 400 is 20. Then we will write 30 plus or minus 20 square root of 2 all over 2. Then 30 divided by 2 is 15, and 20 square root of 2 divided by 2 is 10 square root of 2. Then r equals 15 plus or minus 10 square root of 2. So this equation has two solutions, and one is 15 plus 10 square root of 2, and the other one is 15 minus 10 square root of 2. Now, for our problem, we need to ignore the first solution because 15 plus 10 square root of 2 is approximately 29 units. And this radius cannot be 29 units. Therefore, r equals 15 minus 10 square root of 2, which is approximately 0.86 units. So here we got the solution, and the radius is 15 minus 10 square root of 2, or approximately 0.86 units. And now let's see method 2. With this method, we still have to connect the points D and B. Then let the center of the blue circle be point O, and the point of tangency of these two circles be point E. Next, we will find the lengths of the diagonal DB by using the Pythagorean Theorem, and we can write that BD equals square root of 5 squared plus 5 squared, and we can do this because BD is also the hypotenuse of this right triangle. Then 5 squared plus 5 squared is 50. And to simplify square root of 50, we will write 50 as a product of 25 and 2. Then square root of 25 is 5, and we will keep 2 inside the square root. So we found the distance from D to B, and that is 5 square root of 2. Now notice that this diagonal contains 3 line segments, and they are DE, EO, and OB. DE is equal to 5 and EO is equal to R. So we will write that DE equals 5 and EO equals R. And now to find OB, we will form a square with side R. Then according to the Pythagorean Theorem, OB equals square root of R squared plus R squared. So again, OB equals square root of R squared plus R squared, which equals to square root of 2R squared, and because square root of R squared is R, the result will be R square root of 2. And now we will write that DE plus EO plus OB equals DB. So again, DE plus EO plus OB equals BD. From here, we will replace DE with 5, EO with R, and OB with R square root of 2. On the right side, BD is equal to 5 square root of 2. From here, we will solve this equation and we will find R. We will start by subtracting 5 from both sides, and then from these two terms we will factor out R. When we factor out R, then in parentheses we will have 1 plus square root of 2. Then on the right side we will have 5 square root of 2 and minus 5. To get r alone, we will divide one side by 1 plus square root of 2 and the other side by 1 plus square root of 2. Then on the left side, 1 plus square root of 2 cancels. Then r equals 5 square root of 2 minus 5 over 1 plus square root of 2. Now, to simplify this expression, we need to rationalize the denominator. For this, we will multiply the top and the bottom of this fraction by the conjugate of this denominator, which is 1 minus square root of 2. So we will take 5 square root of 2 minus 5 in parentheses, and we will multiply it by 1 minus square root of 2. Then we will do the same in the denominator. From here, we will use FOIL, and 5 square root of 2 times 1 is 5 square root of 2. Then 5 square root of 2 times negative square root of 2 is minus 5 times 2. And that is because square root of 2 times square root of 2 is 2. Then negative 5 times 1 is negative 5. And negative 5 times negative square root of 2 is positive 5 square root of 2. If we do the same in the denominator, then 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. Then square root of 2 times 1 is plus square root of 2. And square root of 2 times negative square root of 2 is negative 2. Now, in the numerator, negative 5 times 2 is negative 10, and negative 10 minus 5 is negative 15. Then 5 square root of 2 and another 5 square root of 2 makes 10 square root of 2. So in the numerator, we will have negative 15 plus 10 square root of 2. Now in the denominator, negative square root of 2 and positive square root of 2 will cancel, and 1 minus 2 is negative 1. So we will divide the whole fraction by negative 1. And now negative 15 divided by negative 1 is positive 15. And 10 square root of 2 divided by negative 1 is negative 10 square root of 2. And this is approximately 0.86 units. So we found the radius of the blue circle using the second method, and we got the same result of approximately 0.86 units. I hope you enjoyed both of these methods. Please subscribe, leave a comment, and thank you for watching.